run through a little demo of using Julius Busecke's sea surface temperature rise with Coiled. I'm just going to go ahead and do kernel, restart kernel and run all cells, and we'll kind of walk through as this thing is running just to get a good benchmark. So first we're just closing any client or cluster if they're open already, like if we forgot to close. And then we're going to specify cluster type coiled here. And if cluster type coiled, we're going to spin up a cluster on Amazon US West 2, and we're going to use spot instances unless they're not available. Then we're going to fall back to on demand. We're going to use ARM processors. We're going to wait for all the workers to show up. This is a software environment built with Conda that is stored on Coiled, so I can just call up that environment. I don't need to build it every time. And I'm going to just specify 4 workers here just to compare it to a Google Cloud simulation that's similar. And I'm going to specify sort of which account, which is called a workspace, to use, so to get which is going to get charged. So if I do that, it's telling me what it's doing here. It's spinning up. It's the scheduler is starting. It's requested these 4 workers. Let's go down a little bit. You can see that the workers are provisioning, then booting, and then downloading the software. So as soon as they're ready, we can start the dashboard and see what's going on here. Usually it takes a little bit of time for the jobs to get scheduled, but we can look over here. So it took about like a minute and a half, maybe a minute or so to get our cluster. If we look over here, we can see where we are in the notebook. So we're actually going to start loading these data sets. And looks like we're waiting to process this data. Okay, so yeah, so we're opening these data sets and reading like the coordinate data for all these different climate simulations. And then eventually we can see there's 4 workers, but there's 4 threads on each worker, so we have 16 horizontal bars here. You can see they're kind of cranking along through opening up these data sets and getting the information they need. And now we're into the computation of the global mean sea surface temperature. So you can see this like these weight checks and some aggregations and stuff like that. So again, this is parallelization that happens automatically because of Dask in the background, because Xarray uses Dask and Dask arrays under the hood. So the user just says take the mean, and it goes off and does all these calculations in parallel. So let's see, so where are we in the notebook? We are we're done. Okay, so we're done, and it took 75 seconds to spin up the cluster and 75 seconds to run the computation on these 16 threads, 4 workers with 4 threads. Yeah, so if we want to go see now, the kind of cool thing is if we want to go to Coiled and see what just happened, they've got some pretty nice stuff here. Like we can go to, let's see, there's clusters, and there's these different teams. So if we can go to, let's make this a little bigger. We can look at a particular team like eCIP Lab, and we can see what workspaces are. Actually, this workspace is eCIP Lab. The organization is eCIP Lab, and this is the workspace with these 2 users. So then we can go to the dashboard, and we can go to the workspace eCIP Lab, and we can see this was the 4 worker cluster that just ran a minute ago. It ran for 2 minutes, cost about 2 cents. Used these so-called less than 1 of these so-called coiled credits. There's some interesting stuff here. If we click on it, we can see actually what happened over time, with the different kinds of tasks. We can go to metrics and see like how much CPU and memory and disk was used, and if there's errors, we can look at the logs and stuff. So it's a pretty cool diagnostic set that comes along with Coiled. So I'm a big fan of Dask and Coiled for the flexibility and the information that we get back. So I hope that gives you an idea of how the kind of workflows we do with Dask and Coiled.